We are going to talk about generics. And generics are actually one of my favorite things because it eliminates a lot of extra typing, which I'm all for. So we're going to take a look at what generics are, and I will show you some examples of how they can be used. So basically, um, what a generic means is that you're using kind of like a dummy value instead of a data type. So it actually replaces a data type. Um, and you can create generic classes and interfaces, fields, methods. You can actually use this in all sorts of different ways. Um, But what you have to remember is that instead of declaring a data type like int or string, um, you use a generic data type instead, which can be the letter T. Okay. Um, so uh, it makes your code a little bit more flexible, and I will show you why. If you have a situation like this, where you had to overload a method uh, for different data types, right? All I want to do is print an array. And you'll look at for each, the code in each of these methods is identical. The difference between the methods is the data type, the array that I am passing is a different data type. That is the only difference. This is a perfect example of when generics should be used. So what a generic does is it lets you create one method with a generic data type. And then what C# does is it looks at your code to see what types of arrays that you've created, and it actually generates code for each method. So you can create one generic that would replace all of these. Okay, and so that one generic, to create it, you literally can copy and paste one of these, but everywhere that you would normally put the data type, you add a generic. So we've got static void, we keep the same name, and then in angle brackets, we give it a generic. Usually it's just one letter, and quite often it's a T. Um, and that's just because this is kind of like a template. Okay. And then, so this letter, whatever you give it here, is going to be used instead of the data type. So everywhere that I would normally put a data type, I put in the letter T. So in this case, it's going to represent string, double, character, everything that I would have pulled in using the array. So T is my data type. Okay. And then in my for each, normally you give it the data type as the first thing. And so my data type is T. Okay. And this can now replace all three of these. Okay. And so how this works with C# is that it looks to see what kind of array I am passing print array, because print array is taking in an array. Okay, so here's my little program. Here I'm calling print array, and I'm passing it this integer array, which is a data type of integer. So C# sees that, and it takes this, which you can kind of look at as a template. Okay, it takes this generic and it creates an integer version. Okay, so it creates this version. The compiler does this, okay? And then it looks at my next call to print array, which is a double. So the compiler, when it's compiling this program, creates this version. Then it goes down and it looks at this one, which is character. And so when this program compiles, the compiler is going to create this version. So this one generic, when it's compiled, is going to have the different versions that I need for the program to run. And that's kind of all done behind the scenes. Okay, so this one little generic can replace those other three, and it works perfectly. So I'm going to show you how this works because it's pretty darn slick. Okay, so when I run this, it compiles first, okay, and then it runs. So I could just do a build. That'll make it compile too. Now, let me see. Integer array. Okay, let's try that again. Here, let's build. There we go. Now it'll run. When I copied it, for some reason, it was missing that. And that is like a key because it tells you that it's a generic. So that is a very important component. How many numbers do you want to enter? Or let's do 5. So here we've got our random integers, random doubles, random characters. And so you can see that it did run through the print. Okay, and it did create the different versions that it needed to. So if we are going to use this in a class, here you can see I have one that I've created. We put the generic up here, and that is going to be used in place of a data type. So this is actually kind of cool because it lets you create objects that have properties that are all different types of data. So here I've got student, and you can see I've got public T is my data type, and then I'm just calling the field data. Okay. And then I've got a little constructor here, and I am kind of pulling in data, this dot data equals data, and then I just did a little write line so you'd be able to tell what is being stored, because in our main program, we're going to send it a string, then we're going to send it an integer. We're going to send it different data types, and it's going to handle it because this is generic. So in the main program, you can see I declare student, okay, or I use student as my class, but because I have the generic, I have to tell it what type. Okay, and then I give my object a name. And so I've got new student, and again, I have to tell it the type, and then I send it Mickey Mouse. Well, with the exact same class, now instead of a string, I can use an integer. Okay, and then with the exact same class, I can now go back and use a string, and I can create objects for the different data that I want to store. So I've got student name, ID, and major, and I've used the same class to create all of them. Okay, so let's take a look at that. All right, so we've got our generic type, and we've got the three things we're creating. And I'm going to comment this out for a minute. And we're going to run it. So the data passed was Mickey Mouse, and then for the second one, the data passed was 50, and the third one, the data passed was entertaining. So you might be wondering, well, okay, so this was all the same class, and I created it with a generic. Is C# going to recognize that those objects are not the same? Well, let's check that out. So we'll compare the student name and the student ID using equals and see if C# thinks they're the same. And then we'll compare the name to the major. Those are both strings, and see if C# recognizes that they're different. So in both cases, when it compared Mickey Mouse to 50, it recognized it was different. When it compared 50 to entertaining, it also recognized it was different. So it wasn't looking at the data type, it was actually looking at, what it was storing. Which basically gets back to the looking at the reference location. So here's another example. And for this one, I have a class called my generic array. Okay, and it's private. And then you can see I've got public my generic array where I create it with a size. And then I've got a get and a set where I'm indexing in. Okay, and because this is generic, I can create an array of any data type. Okay, and that is basically what you have to realize here. So I'm going to go ahead and copy this and run it. So the first one I'm doing is integer. And you'll notice that I do have to pass it a size because when it creates this array, it has to have a size. So when it comes through here, it knows the C# compiler has already created a version of this that has replaced T with int. Okay, because I tell it it's int here. So when it compiles, C# has done a version of this with integer. So it's going to create a new integer array, and now I'm telling it the size. And so here I'm filling it in with values. Okay, and the values are simply, I'm sending it the index number, and then I'm just multiplying the index number by 5. And that's what it's putting in for values. Okay, and then the get is pretty straightforward. It's just retrieving the values and writing them to the console. Now I also am creating a character array. So when C# saw that, it created a character version of this. And so then I'm filling it in with some kind of random character values. And so I've taken these numeric values and I've converted them to a character using a typecast. And then you can see I'm just retrieving those values that got converted. So let's see. You should be able to see that this is working. That's just another example. So in summary, understanding and using generics are going to improve your programs because you can reuse your code. You can create your own generic classes, methods, interfaces, and delegates. We haven't talked about delegates yet. We will in upcoming weeks. And you can also create generic collections, and we will be talking about collections next week. Not only that, but you can understand how existing generic collections work. And we are going to be using in .NET, there's a lot of generic collections, and we will be using them. So having this foundation and how generics work is going to help you when you go to use the existing collections. Primary advantage of generics is reusability, because obviously a generic class or a method can be used for all sorts of different data types. Also, you have what's called type safety. So what that is that if I'm creating this as an integer and it's compiled an integer version, then I have to fill it with integer values. Okay. Or if I create a character version, then I have to fill it with character values. And obviously performance is improved. And that is because we don't have to do typecasting. We don't have to box or unbox objects and variables. And the performance will be improved because of that. Also, we're letting the compiler create these different versions.